Okay, so here's a little bit harder example. So let's show the base case is true. So we know that let's see if the first sum is indeed 1. So we're going to do 3 to the 1 minus 2, 1 over 2, which is going to be 3 minus 1 over 2, which is 2 over 2, which is indeed 1. So the base case holds. Since we know that the base case works and that this left side does indeed equal that sum, what we want to do is we want to add one more term to each side. So for this case, since we're going to use 3 to the n plus 1 minus 1, remember this here is I'm adding the n plus 1 term. Now what I could do is on the right hand side I got to find the sum for that n plus 1 term. Okay, so on this left hand side, let's see what that simplifies to. Well, let's see. We know that 3 to the n minus 1 over 2. Now when I multiply, well, first off, yeah, the minus 1 here. The plus 1, I need my pointer. Plus 1 minus 1 cancels off, so that leaves me 3 to the n. And now it'd be nice if this were a single fraction, so I'm going to multiply this side by the common denominator of 2 over 2. So that's going to leave me 3 to the n minus 1 plus 2 times 3 to the n all over 2. So that leaves me, let's see, what do I have for like terms here? I have a 3 to the n and a 2 times 3 to the n. That gives me 3 times 3 to the n minus 1 all over 2. So that's the left hand side. Now I'm going to have to verify the right hand side. So I've got this left hand side simplified. Now I've got to simplify this right hand side. Now here's the twist that we have to remember. When we raise a base to an exponent, and we're multiplying two numbers. Let me restart. Suppose I have 3 to the second times 3 to the fifth. Well, the rule for exponents is you're going to add those exponents to get 3 to the seventh. Well, this also is true when we have a when we're raising a power. When we're adding the exponents, we know that's the same thing as multiplying. I have 3 to the n times 3 to the n to the first. That would tell me to add those exponents. So if we take a look at this side and replace that, I'm going to do 3 times 3 to the n minus 1 over 2, and that's exactly what we got on the left hand side. So thereby, mathematical induction, we show that is indeed the true sum.